Okay, so this will be video 2 in the physics video series. We're going to be continuing talking about vectors and scalars and stuff. Now we're going to be talking more specifically about vector operations. Today we're going to be talking about a little more about scalar multiplication, vector sums, how to exactly to represent positive, negative vectors, and how exactly that all plays in. Then we're going to get into a little more advanced level of vectors a little later on. I will probably do a separate segment on vector calculus, but that will be coming a little later. We're going to be talking about more of a physics-oriented stuff. We're not going to be talking too much about advanced differential calculus concepts in physics. It's not going to, like I said in my previous video, it's not going to be that advanced of physics quite yet. So without further ado, we have Ka, where K is going to be a constant, a scalar constant, where you multiply by a vector. And when such that when K is greater than 0, sorry, less than, sorry, I'm reading it wrong. Okay, so back at the very top, we have K, which is a constant, multiplied by A, which is the vector, such that K is greater than 0, you're going to get a positive vector. Again, when you have, well, assuming your A is positive to begin with. So, like I said, with scalar multiplication, like if you have 2, like if you scale it by 2, like I did in my previous video, you will get, twice the magnitude of your vector, and it's going to stay positive. It's going to stay in its current direction. Now, if you multiply it by you do the same thing, but such that K is less than 0, you're going to get negative vector. So I said right here, direction reverses. That's the way to look at it. So tying it all together, we can simply state that the magnitude of a vector can be given simply by K times the absolute value of A. Again, K being the scalar constant. Now, what if we wanted to add vectors? This is not really that hard of a concept to really understand. Basically, what you do is you take one vector and you take another vector and you simply add them together. Now, this can be done in a simpler method. This looks a little, vague and abstract. How did I exactly do? I just, get this little, point right there. I mean, it looks nice that I drew a, nice little diagonal from the center. But really, you can do this using matrices. If you add the two vectors, you will actually end up getting this particular arrow on the graph. If you graph in real too, which is very convenient, makes things a lot more simpler. Because all you simply do is just add the two vectors. And so, the vector sum is simply just like if we wanted to talk about all the forces, the sum of all the forces acting on a body, we would do the vector sum. All the vectors. Like let's say, force A is pushing this object, and the force B is pushing this object, simply given by the sum of the vectors. Pretty intuitive, I think. I'll just simply add all the vectors, you get the vector sum. And as I said down here, linear algebra method for this. So again, basically a scalar multiplication is simply just taking a constant, multiplying it by a vector, and you will get a the vector will simply just change its either direction, it's negative, and also it can potentially change its magnitude. Like if you multiply it by a half, the vector size will go down, and if you multiply by more than 1, then it'll obviously scale up. Scalar scaling up, that would make quite a bit of sense. So this will essentially be the end of this video. We talk a little bit more about a vector, little other vector operations. We're going to talk about vector multiplication, that sort of thing. And then we're going to be talking about using vectors to analyze problems. But that's all to come in the future. We're not going to be getting too advanced into that. We're just going to be talking about how vectors can be used to solve problems involving sort of like a geometric aspect to it, like such as free falling bodies, like you have like a tennis ball and it falls, free falls, or if you throw it at a slant, how vectors can be used to basically analyze the trajectory. Sorry about that. Analyze the trajectory of the object. So that's all for this video. Hope you guys enjoyed. See you in the next.